Alrighty. So let's take a look at homework-wise. You guys said you were all good? Yeah? Okay, again, on these ones here, and I've had somebody else come and ask me a question about this after school yesterday. When it says, find the indicated nth root or roots of, and then it gives you this, okay? Sorry. When it gives you n and it gives you a, it wants all of the fifth roots of -1, all of the fourth roots of 256. So when do we have to worry about putting the plus or minus? Who can tell me when do we have to worry about putting plus or minus? Josh?
When the n is even.
When n is even and a is positive. Very good. Okay? Questions? Then evaluate without using technology. That means no calculator. No calculator. How'd you guys do here? Need me to talk through any of these? Okay, and then these ones, you just match the radical form to the rational exponent form. Good there? That should have been pretty easy. These ones, evaluate using technology, so you use your calculator. Same thing here. And then these ones were solved. So on these ones, make sure you guys are showing me a little bit of work of how you're getting, just a little, okay, how you're getting the answer. You can't just have an answer down. All right, any questions at all? All righty, pass them in. Today is like an entire review of Algebra 1, one chapter, and one lesson. And we're doing it with fractions. Feel the love. So you've learned all these rules in Algebra 1. 3, 4, 5. Sleepy. I could not go to bed last night. Oh my goodness gracious, it was terrible. I was laying there going, you know how you get to that like panic stage where you're like, I really need to be asleep by now. I should be asleep by now. And the more I panicked, the more I couldn't fall asleep. Huh?
I woke up, took a 6-hour nap, woke up at 10, I couldn't fall asleep.
6-hour nap?
I was so mad.
That's pretty impressive, dear. All right. Okay, so today, what we're going to deal with today is we're going to talk about using all of our exponent rules, but we're going to do it with rational exponents. So that means with fractional exponents instead. Okay? You have learned all of these properties in Algebra 1. You may or may not remember them. Okay? I left this blank for you guys to fill in on your guided notes. Product of powers. That means if you take two powers and multiply. So if you multiply powers, a to the m times a to the n, what do you do to the exponents? Add them. You add them. That's a to the m plus n. Keep in mind you have to have the same base. A to the m times a to the n is a to the m plus n. You have to have the same base. So if I have 5 to the 1/2 times 5 to the 3/2, what math do you do? 3/2 plus 1/2. What's 3/2 plus 1/2? 3/2 plus 1/2 is what? 4/2. And what's 4/2? 2. And what's 5 squared? 25. So we did these in Algebra 1, but we just had 5 to the 2nd times 5 to the 3rd. Now you have 5 to the 1/2 times 5 to the 3/2. So you have fractions. Add the fractions. Add fractions have to have common denominators. Okay? Are you guys good there? Because I know you're copying, so I want to make sure I give you enough room. Power of a power. Power of a power is if you have a to the m raised to the nth. What do you do if you have a power of a power? You guys remember? I heard it. What? Multiply. So that is a to the m times n. A to the m times n. So my example is 3 to the 5 halves raised to the second. Okay, what math am I going to do? Multiply what? 2 times 5 halves. Now, so many times you guys grab your calculators and you drive me nuts. When you multiply 5 halves times 2, 2 is over 1. What happens to the 2's? They cancel. So what's your answer? 3 to the 5th, which is 243. Next one is power of a product. So if you have A times B to the n, it does not work if you have plus or minus. If you have plus or minus, you have to FOIL it out that many times. But if we have A times B to the m, what do you do with the m? Distribute it or share it with both of those. A to the m times B to the m. So that outside exponent goes to both the A and to the B. Again, that only works with multiplication, not with plus or minus. So if I have 16 times 9 raised to the 1/2. If I gave this to you and told you no calculators, some of you might go, I don't know what 16 times 9 is. But, Laura, what can we do with this 1/2? Give it to both. So you get 16 to the times 9 to the 1/2. Well, when something is raised to the 1/2, we learned yesterday that that really means the what, Laura? What root?
What?
What root? If I 16 to the 1/2, if I asked you to write that in radical form, what would it be? It is. So you need to look at this and start seeing this as, that's just the square root of 16. This is just the square root of 9. What's the square root of 16, everybody? 4. What's the square root of 9? What's 4 times 3? Well, we didn't touch a calculator. Questions on that one? We talked about our negative exponent rule yesterday. If you have a to the negative m, where does that go? To the denominator. Now, there's a little exception to this rule in the fact that you cannot have a equal to 0 because if your denominator is 0, you have an undefined value. So keep in mind a cannot be 0. So once again, if I give you this problem, no calculator, 36 to the negative 1/2. Chloe, what do I do if I have a negative power? Put it on the bottom so it becomes 1 over. And what is 36 to the 1/2 mean? Square root of 36, which is? So your answer is 1/6. Good. Questions on that one? The 0 exponent. This is the one you guys always like, I don't know, it's so easy, you make it hard. What's anything to the 0 power? 1. Anything to the 0 power is 1, except for 0. So what is 213 to the 0, everybody? 1. Anything other than 0 to the 0 power is 1. Am I going too fast or are we good? You guys able to write? All right, quotient. What's quotient mean? Division. So what do we do when we divide powers? A to the m divided by a to the n. What do? Anybody remember? Subtract. And it's always top minus bottom. Top minus bottom. Again, a can't be 0 because you can't have a denominator of 0. So a to the m divided by a to the n is a to the m minus n. So you're going to subtract your exponents. Remember, adding and subtracting fractions have to have like denominators. So I have 4 to the 5 halves over 4 to the 1/2. McKenna, what are you going to do?
You do 4 and then in quotations do
3/2, or 5/2, and then minus 1/2.
Which is?
4/2.
Okay, don't be telling her I can hear you. What's 4/2 reduced to?
16.
Okay, 4/2 reduces to 2, and then 4 squared is 16. Okay, good. How'd you guys do on that one? Do you remember these rules from your 8th grade or freshman year? No? It was a whole chapter. Each day was like 2 rules. It's coming up right now for it's chapter 6. And the last one, power of a quotient. This says if you have a power of A divided by B, what do you do with M? Share it. Give it to both. You know, I don't like the word distribute because it's not really the distributive property, but you are giving it to both, so I see why you guys say distribute. It goes to both the A and the B. Again, B can't be 0 because you can't divide by 0. So I have 27 over 64 to the 1/3. So Ty, what do I do with the 1/3?
Share it.
Share it. And what does it mean when you have 27 to the 1/3 and 64 to the 1/3?
27 cubed. So
Not cube, cube root.
cube root. Yeah.
Cube root. Because cubed would be like 27 times 27 times 27. The cube root of 27 is what multiplies 3 times 27. And what is the cube root of 27?
30.
And what's the cube root of 64?
4.
4. Good. All right, so those are all of the rules that we're going to work with today. And we have one other little property that we're going to talk about, but this is the big part of today. Has everybody got that copy? Do I need any more time? All righty, so use the properties of rational exponents to simplify the expression. Guys, this would be expected with no calculators. Okay, so what are we going to do here? Landon.
You just add the 1/4.
Good. Now, I know you guys might not write the add, the 1/4 and the 1/2. That's fine. You don't have to write that red star part. What is 1/4 plus 1/2?
3/4.
3/4. Now, if you don't remember how to add fractions, you guys know what 1/4 plus 1/2 is, but let's just review that real quick. Remember, you have to have common denominators. So the common denominator would be 4. You'd have to multiply that by a 2 and that by a 2. So that's how I got 1/4 plus 2/4, which is 3/4. And you guys know what 1/4 plus 1/2 is. All right, let's go to the next one. You cannot add the 1/2 and the 1/3 because they are not the same base. Do you guys see that? This is a 6 and this is a 4, so we cannot add those. So Jordan, what are we going to do with the outside squared? Yeah, give it to both. Distribute. So you have 6 to the 1/2 squared and 4 to the 1/3 squared. Again, that's how I think about it. You can skip that first step. And what do you do when you have a power of a power?
Just
Multiply? Okay, what's a 1/2 times 2? 1/2 times 2. 1/2 times 2 over 1. What happens to the 2's? And you just left with 1. Do you see that? Okay, so this is 1. So 6 to the first, or just 6, times, and then what do you get here?
1/6.
Careful, you have 1/3 times 2 over 1. So multiply across the top and across the bottom. 2/3. Good. Now, can I simplify 4 to the 2/3 at all? You cannot. This one's kind of weird. So we're done at this point in time on this one because you cannot. Can I take the cube root of 4? No. And if I square it first and get 16, can I take the cube root of 16? So I'm done. I'm done. Do you guys have C on there? Okay. C is a weird one. So I want you to watch. What do you guys notice? 4 to the 5th times 3 to the 5th. I do not have the same basis, so I cannot add these 5s. But what do I have here? Do you guys see how I have the same? So I'm going to undo, okay? You guys recognize that if I have A times B to the mth power, it's equal A to the m times B to the m. Can I go backwards? Absolutely. So if I have A to the m times B to the m, 4 to the 5th times 3 to the 5th, can I go backwards and say that's 4 times 3 to the 5th? Okay, so I'm going to say 4 times 3 to the 5th, all to the what? Well, what's 4 times 3? 12. And then power of a power, what are you guys going to do here? Power of a power, what are you going to do? Multiply. What's 5 times negative 1/5? Negative 1. Can you leave a negative exponent in your answer ever? So what does this become? 1 over 12. Thoughts on C? Okay. D? Karina, what's my invisible exponent up here? 1. You have 5 to the first over 5 to the 1/3, or 5 to the first divided by 5 to the 1/3. So what do you do with your exponents? I'm sorry? Subtract. So you're going to subtract 1 minus 1/3. What's 1 minus 1/3? 2/3. Now, if you don't know that, write out. You have 1 over 1 minus 1/3. What would your common denominator be? 3. So you got to multiply that by 3 and that by 3, so you get 3 over 3. So 3 over 3 minus 1 over 3 is 2 over 3. Can I simplify this at all? Can you take the cube root of 5 or 25 if you square it first? No. So we're done. Any thoughts on what to do here? Okay, can't cancel the exponents. But do you guys remember the rule that says A over B to the m is A to the m over? Can I go backwards? Do I have the same exponent here and here? So can I think of this as 42 over 6 to the 1/3, all squared? So what is 42, and maybe somebody said divide and that's what you meant. I thought you were talking about the exponent, sorry. What's 42 divided by 6? 7. And now what do you do when you have a power of a power? Multiply. And what do you get when you multiply? 2/3. Again, when you multiply 1/3 times 2 over 1, you get 2 over 3, 2/3. Questions there? And we can't simplify that because there's no cube root of 49 and there's no cube root of 7. Are we good? So you have a part of your homework tonight is this. All these rules with fractions. Questions? Okay, the second part of your homework tonight is going to deal with the fact that, and you guys know all these rules, we can separate radicals up. For example, square root of 12. Okay, did I leave you any room after the slide? I sure didn't, did I? Okay, square root of 12. What can I break square root of 12 up into? Square root of 4 and what's the square root of 4? 2 square root of 3. So we did that this year. what if I give you the cube root of 24? Now I'm not looking for a perfect square that goes into here. I'm looking for a perfect what? Cube. I'm going to come off to the side and make a list of our perfect cubes. Okay, let's talk about perfect cubes. 1 never helps us because breaking something up into 1 doesn't, but 1 is a perfect cube. 1 times 1 times 1. What is 2 to the third? 8. What is 3 to the third? 27. What is 4 to the third? 4 times 4 is 16 times 4 is 64. What's 5 to the third? 125. And the last one you need to know is 6 to the third. What's 6 to the third? 16. Okay. So I look at the number 24, and since it's cube root, I'm going to say, do I have any perfect cubes that divide evenly into here? 8. How many times does 8 go into 24? Do you guys agree that that's a legal move? What's a cube root of 8? 2. So this is 2, cube root of 3. We are also going to deal with fourth roots. Fourth root of 32. So we're going to look at perfect fourth roots. Again, 1 doesn't help us. What is 2 to the fourth? 2 times 2 is 4 times 2 is 8 times 2 is 16. What's 3 to the fourth? Remember we talked about having, I think I showed you guys this. If I have 4 3s, instead of doing 3 times 3 is 9 times 3 is 27 times 3 is 81, do it like this. What's 3 times 3? 9. What's 3 times 3? 9. What's 9 times 9? 81. Okay? 4 to the fourth. Do you guys know 4 to the fourth? 256. And how about 5 to the fourth? What's 25 times 25? 625. All right. So now as I go back and look at the fourth root of 32, do I have any perfect fourth roots that go evenly into 32? 16 and 2? What's the fourth root of 16? 2. So this would be 2, fourth root of 2. So the first rule, the product property, just says we can break up any root into a product of 2 roots, just like we did square root of 12. Okay, just like we did the square root of 12. And remember when we had square root of 50 over square root of 2? The first thing we could do is ask ourselves, can I divide 50 by 2? What's 50 divided by 2? And what's the square root of 25? Now, that's using square roots. We did that last fall. What if I give you cube root of 81 over the cube root of 3? Can I apply those same principle? Yes. Since it's both cube root, that's the cube root of 81 over 3. What's 81 divided by 3? 27. What's the cube root of 27? 3. Fun stuff. All right, now this next one's really big, and I promise you the ones that I give you on the test without a calculator will be easier numbers than this. Does anybody know what 12 times 18 is? 12 times 18. I heard it. 216. And what's the cube root of 216? It's on your list. 6. What are we going to do here? 80 divided by 5. Do you guys know what is 80 divided by 5? 16. And what's the fourth root of 16? 2. All right. We are not in simplest form unless no radicans have perfect nth powers as factors other than 1. So that means, like, we broke square root of 12 up into 4 and 3. Or you broke, what other ones did we break up? Square root of 24 up into, or cube root of 24 up into cube root of 8 and cube root of 3. If you can break it up, you have to break it up. You cannot have fractions under a radical sign. Because if you have a fraction under a radical sign, that really means the radical of this over the radical of that. Now you have a radical in the denominator, and that's a problem. Okay? And you cannot have radicals in the denominator. To meet these last two conditions, we sometimes have to rationalize the denominator. Do you guys remember doing that? If you have the square root of 3 over square root of 2, what did we have to do to simplify this? Multiply top and bottom by square root of 2. What's the top give us? Square root of 6 over square root of 4, which is just 2. Do you guys remember doing that last fall? You can't have a radical in the denominator. So you rationalize the denominator to get rid of that. It's a little different with higher degree radicals, but we'll talk about that in a minute. All right, write the expression in simplest form. Okay, cube roots. So we got to figure out what perfect cube would divide into 135. So think about your list of perfect cubes. We got to go to 135. So obviously 135 fits right here. Does 125 go into 135? No. Does 64 go into 135? 27? Possibly. 135 divided by 27. Does it go in evenly? Yeah. So what are we going to break this up into? Cube root of 27, cube root of 5. This is a hard one because it's not easily recognizable. What's the cube root of 27? 3. Cube root of 5. When you do your cube root, your index right here, make sure that number is small and inside your little radical, okay? All right, this is where it gets a little tricky. So I'm looking at this and saying, okay, I have fifth roots. I see that. But can I divide 7 by 8? No. Now, you cannot just multiply by the fifth root of 8. Because the fifth root of 8 times the fifth root of 8 is the fifth root of 64, and that did not help me. So you have got to think about your perfect fifth roots. So let's think about our perfect fifth roots. What's 2 to the 5th? What's 2 to the 5th? 32. Could I turn this into a 30? Could you turn the 8 into a 32? Let's think about this. Could I make this that? What do you guys think? What would I have to multiply this by to get to that? Fifth root of 4. Whatever you do to the bottom, you do to the top. So we already did the bottom. Fifth root of 8 times fifth root of 4 is fifth root of 32. What's the fifth root of 7 times the fifth root of 4? Fifth root of what? 20. What's 7 times 4? 28. So fifth root of 28. Well, what's the denominator give me? What's the fifth root of 32? 2. And can I break that up into any perfect fifth roots? Well, 2 to the fifth is 32, and that's smaller, so nope, not going to break it up at all. And we're done. I know, these are just thinkers, aren't they? I want you guys to think about C and D. See if you can get C and D. So Jack, well, what'd you break 500 up into? That's a perfect cube.
125 and 4.
125 and 4. Do you guys agree with that? Mm-hmm. Yes, perfect. And what's the cube root of 125, Jack? 5. So it's just 5 cube root of 4. How'd you guys do on C? Did you do okay? Still working on D? I was done. All right, what's the perfect fourth root that we could turn 4 into? Yeah, think about this. What's 2 to the 4? I always start, what's 2 to the 4th? Can I turn that into a 16? Yeah. What would I have to multiply this to make this be 4th root of 16? I'd have to multiply the 4th root of what? 4. Whatever you do to the bottom, you do to the top. What is 19 times 4? 4th root of 76. What's the 4th root of 16? 2. Now, I'm just going to double check. Can 76 be divided by 16? No. And then the next perfect fourth root would be 81, right? 3 to the 4th is 81 is not going to go in. So we're done. So we cannot break that up. I'm done. Do you guys see what I was checking there? I was checking to see if I could break the square fourth root of 76 up. All right, last two. The denominator, that is the sum or difference involving square roots, you multiply both the numerator and the denominator by the conjugate. Okay? Remember, what's the conjugate to 5 plus the square root of 3? 5 minus the square root of 3. Whatever you give to the bottom, you have to give to the top. Now, when you multiply your numerators, well, this is just distributive property. What's 1 times anything? Itself. Denominator, I have to FOIL. Are you ready? What's 5 times 5? 25. 5 times negative square root of 3. Negative 5 square root of 3. Square root of 3 times 5. 5 square root of 3. And what's square root of 3 times negative square root of 3? Be careful. What's a positive times a negative? And what's square root of 3 times square root of 3? Square root of 9, which is just 3. What happens to your middle terms? These cancel out. Those go away. And what is 25 minus 3? 22. And now we're done. Don't have a radical in the denominator. What do you guys think about that one? Yeah. Be careful here. I don't like the way this denominator is written. put it in standard form. What's standard form? -2 plus the square root of 7. Because now when you multiply by the conjugate, what is the conjugate? It's -2 minus the square root of 7. What do we do in the numerator? Distribute. When you distribute, first was 4 times -2. -8. No, 4 times negative square root of 7. Minus 4 square root of 7. 4 is on the outside. The 7 is under the radical. It stays that way. There's my numerator. Denominator. We're going to FOIL this. I'm going to FOIL under here. What's -2 times -2? 4. What's a negative times a negative? Positive. What's a positive times a negative? And what's a positive times a negative? And square root of 7 times square root of 7. What happens to the middle terms? What's your denominator? That was a long lesson. I didn't expect that today. All right. Homework. Page 242, 2 through 30 even. 242, 2 through 30 even.